Yeah, good morning, all of you. In this session, we are going to discuss about the architecture of Azure 86. So the diagram shown you here is the architectural diagram of Azure 86. So this is such an wonderful and beautiful architecture that you are looking here, and it can uh, divide it into two parts physically. So one is calling it as bus interface unit, and the other one is going to be the execution unit. This dashed line that you are observing on center of this slide is the separation between two units, execution unit on left side and bus interface unit on the right side. And the bus interface unit is going to deal with the bus transfer of data with the memory IO, either to read from memory IO or to write onto memory and IO. So this all deal by this bus interface unit. And coming to the left side, this is where actually the performance, where actually the working of execution is going to be done at this part, calling it as execution unit. And here BIU and EU are going to work separately. So BIU on right side, EU on the left side. Let me see in detail about these. First of all, see on right side bus interface unit. If you observe on bus interface unit, first of all you are looking through address generation. This address generation is dedicated for generating the physical address to access a particular location in the memory, because here the registers are going to have 16-bit, either the base address register or the offset address register, both are containing only 16, whereas for accessing a particular location in the memory it requires 20 bits of address. So to get 20 bit of address from 16 bit of address, so the address generation is going to be useful. So whatever the address that is contained in the base address, that is going to be shifted 4 times left, so that it will becomes the 20 bit, and which is going to be added with the offset address, so which becomes the physical address, which is of a 20-bit address. So because of this, you can access a particular location in the memory. So that is the about address generation. And for making help to the address generation, there are about 4 segment registers are there. These segment registers, each segment register are going to deal with a particular segment in the memory. For easy accessing of memory, the memory is logically divided into 4 parts: one for code, another for data, another for stack, another for extra data. So in this way, so the data related to code or nothing but program will be available from code segment, and related to the data information or operand available from data segment. And if it is not sufficient, we can have one more segment calling it as extra segment. And for relating stack data, so whenever you are dealing interrupts and whenever you are dealing some subroutines, then stack is very much essential. So for dealing the stack data, the stack segment will be there. So for all these segment, the base address or starting address of all these 4 segment are available in a CS, DS, ES, and SS. Let me see more some other details of these code segment registers. These code segment registers, they are going to be either in overlapped, it may be partial overlap, or it may be the non-overlapped also. If you observe the segment 2 and segment 4, between segment 2 and segment 4, there is a space. Hence, we say that these are not overlapped. But whereas coming to segment 1 and segment 2, these are going to be the partially overlapped, whereas segment 2 and segment 3, which are calling it as fully overlapped, whereas segment 0 and segment 1, these we call it as continuing. continuing the segment from one segment to the another segment. So in this way, in physical memory, these segments, either it may be the overlapped or it may be the non-overlap. Generally, they are going to be in non-overlapping case, and for each segment, it allocates 64 kilobytes of data. So it because each segment is of 16 bits, hence 2 power 16 nothing but 64 kilobytes. So each segment allocating it 64 kilobytes. Now let me see about each and every segment register. The first segment register, calling it as a code segment register. This is one of the important. This is one of the pioneering segment register, calling it as code segment register, that will be available as CS. So each code segment register is about 16 bit, and this is where the starting address or base address of the code segment will be available, and this address along with the another value calling as IP, nothing but instruction pointer. These two are used by the BIU to compute the physical address, to compute the physical address. And for computing that physical 20-bit address, the CS is going to be shifted 4 times left. After that, it is going to added with the IP. So because of this, 20-bit will be generated. So this about the code segment register. And coming to the data segment register, similar to the code segment register containing a starting address of code segment. The data segment register DS contains the starting address of the data segment, and for data segment related data, the offset will be available either from SI register or DA register or from the constant 16-bit displacement. So from any one of these, the offset will be available. So this offset address along with the base address provided by the data segment register is used by the BIU to get the physical address for accessing the data in the memory. And coming to the stack, so for stack related data, stack related memory, so stack segment register SS is going to have base address or starting address of the stack segment. And for this, the offset will be available in the SP. So this SP generally we use for pushing of the data and popping of the data in stack. Therefore, SS along with SP is used to provide the physical address to access a particular location in the stack segment of the memory. And sometimes in base addressing mode, instead of SP, we can also use of BP. So SS plus BP for getting the physical address. Now coming to the extra segment. So this extra segment is also for the data only. When data segment is not sufficient for handling the data, for having the data, then we can use of extra data segment. It's nothing but extra segment. Okay, for getting access to that extra segment data, so ESR, extra segment register containing starting address or base address, and either DI or some offset is going to contain the offset address. So because of ES and DI or some offset, so we can have the 20-bit address to access a particular location, particular operand in extra segment of the memory. So with these 4 segments are completed. Other than this, BAU contains IP also, where IP is nothing but the instruction pointer. In some other microprocessors or microcontrollers, it is also called as PC, nothing but the program counter. So either instruction pointer or program counter, so meaning the same, doing the same, that it is going to contain address of the next instruction to be executed. Suppose you are doing some execution of some instruction. After this execution, you need to move to the next instruction. Either it may be below the current instruction It may be far away from the current instruction that is decided by the PC. So PC or IP contains what is the next instruction to be executed. Therefore, this instruction pointer is going to have address of the next instruction. And other than these, the BIU also contains an instruction queue. This is one of the specialty that is involved in 8086 in comparison with the earlier microprocessors. So because of 6-byte queue, so it is going to speed up its execution, because suppose you want to have a data to be executed in the microprocessor, but the data is available at the memory. So for getting the data from the memory, you need to do some fetching operation. Then you need to do some execution operation. All that you need to do at the microprocessor. So for all these, you require some clock. Instead of that, if you are going to fetch 6 bytes at a time from the memory, then it is easy for the microprocessor to get the data which is immediately available in the bus interface unit. So this is useful for implementing the processor in pipeline mode, so that its speed is said to be improved. Speed is said to be improved, and this instruction queue is based on the principle of FIFO, that is first in, first out. First in, first out. Yeah. About the execution unit of architecture that we see in the next session.